Having said that, I think we will have the next speaker, Anjali Chadra. Okay. So the interesting perspective we wanted to share next was, having understood what AI is and what its implications are, the next question we asked ourselves is, what would we do or use the machine learning and AI with the current trend of DevOps and quality engineering transformation that organizations go through, and how do we leverage it? And I'm very happy to introduce our next speaker today, Anjali Chadra. Anjali is a great professional whom I've had the fortune of interacting at various conferences in the US. I've heard her speak in the US on DevSecOps, and she's quite a professional leader in this particular space, and I'm very thankful for her to join. She shares the same burden as I do because both of us are logging in at a very late time in the US. Anjali, thanks a lot for taking time. Without much ado, over to you, Anjali. You have 25 minutes, and then we certainly would love to hear your thoughts on how to leverage the AI and machine learning for DevSecOps.
Thanks. Thank you so much, Pradeep. Thanks for the introduction, and definitely it's a mutual appreciation. I have interacted with you, and I have seen all the work on the QAI side and things like that, and really respect what you do in quality engineering and related space. And thank you for this opportunity. I would also not spend too much time in introducing and things like that. I will start sharing my screen, and do let me know once you start seeing the presentation. So please let me know if my presentation is visible.
Not yet. Yeah, now it is. Yeah.
Okay, and I'll get into the full screen mode just to make sure that
Absolutely.
Okay, so
we can see that.
Great. So in fact, I was listening to the conversation from Mahesh, and I was thinking that it's a good start and a good segue to the conversation that I'm planning to have, specifically around leveraging predictive analytics, machine learning, and AI for DevOps and quality engineering transformation. So Mahesh did share a very interesting perspective around the whole aspect of human intelligence versus artificial intelligence and things like that. My conversation, I'm trying to focus a little bit around the aspects. We have been hearing so much in the industry, and I'm sure all of us have been kind of asked this question at least twice in a week in various conversations, that okay, what is happening in quality engineering space around AI. And there are a couple of aspects whenever I'm into any such conversation. I always say that see, there is one, the aspect of leveraging AI for supporting quality engineering and DevOps transformation, and then there is an aspect of actually testing AI or doing the quality assurance and quality engineering around the AI systems and AI applications. So this conversation today, what I'm going to have is majorly focused on the first part of it, that is leveraging the predictive analytics, machine learning, and artificial intelligence aspects for transformation in the DevOps and quality engineering space. So with that, I'll move on to my first slide, which is let us see where the industry is headed and why there is so much discussion around AI-powered DevOps and quality engineering, why this topic is becoming so important. So as you can see, in the last year, in just 12 months, in the year 2019, starting from Jan 2019 to December 2019, the funding, and these are the US numbers only, the AI-powered development and code analysis tools companies have raised close to $1 billion in funding, which gives us an indication that industry overall is investing in utilizing AI to help the development and testing and the code analysis process. So this just kind of tells you where the money is, and money is flowing into the AI powered development and code analysis tools. Over 50% of IT groups will use some form of AI ops by the year 2021. So just understand that it's a pretty significant number of IT professionals if we say that over 50% of IT groups across the enterprises will use some form of AI ops. It's a pretty significant number, and that's going to happen in 2021. There is a prediction that the custom development applications, or like custom development of applications, that market will see 30% growth. Now, it's again a huge money. If you look at it annually, it's close to $61 billion spent in a year, and that will start happening by year 2023. That means there is a lot of energy that is going to be spent on custom development. How do we expedite that? How do we make sure that the development is happening at the right velocity with right quality without utilizing some of these next gen techniques of AI powered tools, AI powered quality engineering, machine learning, predictive analytics? So all that kind of reinforces the fact that we really need to do something pretty quickly to transform DevOps and quality engineering by utilizing the power of data, power of machine learning and artificial intelligence. Now, there is another very interesting data point, and which was from a report in 2018, which said that the cost of bad quality software across US alone is close to $2.3 trillion. And it was very interesting when I read this report, because it said that, guys, just imagine this is 10% of entire US GDP, something of that sort. So basically a pretty significant financial loss in terms of business opportunity loss, in terms of all the cost of downtimes and production issues and regulatory failures, risk compliance issues, that led to $2.3 trillion. So definitely there is a lot of scope to improve the quality engineering function to ensure that these financial losses do not occur. And then last but not the least, there was a survey that we at TechMahindra, we did it internally with some of our quality engineering teams, and based on their understanding of the engagements they are running in customer environments, most of them believed, and based on the analysis, that 65% of defects in production can be prevented by simply the trend and past data analysis. 65% of defects, which is, again, this can be there can be a factor of subjectivity here. There can be a factor of this is a small group, only tech MQE organizations and things like that. But bottom line, there is a lot of defects that can be prevented by past trend analysis and data analysis. So these are some of the points I wanted to emphasize, just to share that why this topic of leveraging AI and machine learning for DevOps and QE transformation is important. With that, I'll move on to the next slide. Won't spend too much time here. Specifically because we all know DevOps. At least that's how I look at it. DevOps is something which is not new to any of us. We understand in the quality engineering space, in the development space, DevOps practices has been there for quite a while. We are talking about bringing development and operations together. There was a time I would say 5-7 years back, when there was a lot of talk in the industry and everybody was like, yeah, we don't need quality engineering, we don't need QA. Anyways, now it is DevOps, it is Dev and it is Ops. Where is the role of testing? What will testing do? And then we are here today, and quality engineering is becoming more and more prominent. Continuous testing is a term that anybody in the IT development side definitely understands and thrives for that. Yes, we need to implement continuous testing. And that whole aspect, there was in between a time when there was a terminology that also came in the forefront as Dev QA Ops, where there was like there was a community and there was a section that started emphasizing that QA has a central space in the DevOps world. And then obviously DevSecOps, where security also comes to the forefront. You cannot ignore security. There has to be shift left of security. How do I do early security? How do I do early security tests, vulnerability, penetration tests, and things like that? So all that put together, eventually the way I kind of, from a quality engineering standpoint, I segment DevOps is in shift left and shift right. Right? Shift left is something that it is way before the DevOps and agile and all that came in picture. We still, like 10 years back, we used to talk about defect prevention over defect detection. How do I make sure that my requirements are testable? How do I do static testing? How do I ensure that all the requirements are aligned with the right design? So making and building quality into the entire development process, that shift left strategy, I would say that is given. That is something that has to be done irrespective of DevOps or traditional IT. Shift left has been there, and that focus has to increase. Now let us look at the shift right side. As the DevOps evolution and digital transformation started happening, shift right, which is techniques for quality engineering, be it like exploratory A/B testing, or feature toggles, or canary releases, or chaos engineering, all these techniques of shift right are also coming to the forefront. Now, the point that I'm trying to emphasize with this slide is that the complexity of the overall testing as a function has grown multifold. It is obviously there is a change in the operating model because of the whole agile and DevOps alignment. There is a change in the technology stack. There is a change in the underlying infrastructure due to cloud, due to omni-channel, due to IoT. There is a major change and major shift in the infrastructure complexity. Data is growing. There is huge data. There is big data. Data complexity has increased multifold. All that is impacting the testing and quality engineering and overall SDLC and development function. And just by utilizing the traditional techniques, it is very difficult to deliver the right quality at the speed that is being expected. So there is definitely a need to change the way or bring a different perspective using machine learning, using data analytics and AI into the whole DevOps and quality engineering paradigm. Because with the traditional testing and traditional test automation techniques, the level of complexities that we are dealing with today cannot be solved or handled. We have to think out of the box. We have to think of leveraging data. We have to think of making programs learn for themselves to auto heal. Unless we do all that, it is very difficult to manage the complexity of IT systems today. With that, I'm just trying to, I know that these are basic things, but many a times I have been in situations where again, even with me, when we are talking with multiple people, the whole data analytics, machine learning, artificial intelligence, there is that these all are kind of tied together, but still very distinct in what these functions are and what it is meant by that. So I just thought that I'll at least from my standpoint clarify that when I say data and analytics here, it is basically DNA is data and analytics is the process of examining data to draw conclusions about the information it contains. So that is where data and analytics, basically data analytics aspect kind of ends, where you have data, you utilize that data, you examine that data and draw conclusion about the information that is contained in that data. Getting to the machine learning, it is a layer obviously over data. Eventually there is no machine learning without underlying data, but basically the whole machine learning paradigm is it focuses on developing programs that can utilize the underlying data or access the data and use it to learn for themselves. The programs can learn for themselves by understanding patterns, by utilizing machine learning algorithms. They can actually learn for themselves. And machine learning is kind of, for at least for my the way I explain it to myself, it is definitely a subset of AI. Looking at AI obviously is a bit wider range. You have all of your supervised, unsupervised, and various aspects. But basically, when you take the whole aspect of learning from the data to a level where you try to simulate the human intelligence in machines, and in fact, Mahesh just before me was touching on that particular subject, and he has a very strong perspective on that. But basically trying to simulate the human intelligence in machines so that they start to think and behave and mimic human actions. That is where artificial intelligence is. And at this stage, I would like to clarify that so far in my experience, and we at TechMahindra and also with our customers, and I have been talking to a lot of peers in the industry and a lot of conversations. What I understand is that right now, quality engineering and DevOps areas, they are getting pretty mature in terms of utilizing the predictive analytics and the supervised learning functions, utilizing the pipeline data, utilizing the logs data, utilizing the monitoring data. So the first two aspects are getting mature as it comes to applying data analytics and machine learning to DevOps and quality engineering. The whole aspect of human intelligence in machines, auto healing, auto correcting bugs and things like that, auto correcting automation scripts, there is a lot of effort that is being put in that space. Huge success is yet to be seen. So that is where I leave it, because I would say it's a subject which is very you can have hours of discussion just trying to understand that what we mean by when we say that this is being achieved or this is matured or this is still being tried on. But that's how I look at it today. Now, this is basically another aspect which is where I kind of try to emphasize that cognitive DevOps definitely is coming closer, or we are reaching a stage where we can say that I can build cognitive abilities in my DevOps pipeline, where the pipeline itself identifies the risks. The pipeline itself tries to recover from certain environment issues, recover from certain configuration issues, recover from certain data issues. Automation scripts, if they fail, they try to recover from that failure and restart themselves, and all those aspects. Or even taking it up to the stage where production failures can be looked at, triaged pretty quickly. RCA can be done based on the history, the pattern, the trend analysis, anomaly detection, and the pipeline can try to recover itself rather than depending on a lot of human intervention. So that philosophy and that I would say, mission or vision of cognitive DevOps is very much in place. There are organizations, there are IT teams, including us at TechMahindra and a lot of our peer organization, a lot of our customer organization that have started looking at cognitive DevOps. Now, to me, and this I'm again speaking from experience with working with customers who are trying to build something where we are helping them to build cognitive abilities or self-healing, self-recovering type of abilities into the pipeline, that eventually all that is driven by the quality of the underlying data that is being collected by the pipeline execution. So as you go through builds, as you go through releases, as you go through continuous integration, continuous deployment, and continuous testing, every step of that pipeline actually has a data point that needs to be collected, needs to be classified, needs to be identified, needs to be parameterized, needs to be processed for a specific use case to be able to utilize that data effectively and provide intelligence into the overall DevOps pipeline. So that is what this diagram, which probably looks very complex, but actually is not as complex. The top most line on the screen that you see is nothing but your continuous integration pipeline. The middle one is nothing but your continuous deployment pipeline, and the bottom red boxes that are there is continuous testing. It is basically a CI/CD/CD pipeline depicted from the inception of the demand, from there to getting the actual code and system in production. So it is a CI/CD/CD pipeline. Every stage of the CI/CD/CD pipeline actually gives a specific set of data. So if we take an example, if you look at the C stories or the stories or design, that is where majorly all your requirement to design traceability data comes from. As you move from there to the code repository and try to integrate your stories to design to code repository, that is where your traceability from code to design to requirements comes from. And as you move into, in parallel to that, as you move to test design and actual test execution, that is where your traceability of test cases to code to design to requirements comes from. So any type of trend analysis, hypothetically, if on a bug we have to do a trend analysis in terms of origination, the quality of this traceability data is very, very important for that trend analysis to be really helpful or to be really giving me some right indication that we can definitely use. So unless we are confident on the quality of the underlying data, the trends or the anomalies or the predictions, we cannot be confident about them. So that is what I'm trying to depict and highlight from this particular slide, that data collection is the key. When we start thinking about utilizing any sort of data analytics, machine learning, and taking it to artificial intelligence, building in our DevOps pipeline, the first step to that is thinking about how will I get the data? How is my data getting stored? Which are the various systems? There will be so many systems, starting from your ALM tools to your test execution tools to your build repositories to your monitoring environment management, every stage. And then obviously the ITIL, which is where all your production support, operations support is getting captured. All that data getting consolidated, getting tracked, getting stored, getting traced is the key for actually doing anything with predictive analytics, machine learning, or AI in the DevOps and quality engineering world. So with that, I'll move on. This is so Pradeep, is there, okay, is it right? I have around 10 minutes. I'm just assuming that. Please correct me if that is not.
Yes, you do.
Okay. So, I think I will take this slide little bit slow. I'll basically I'm trying to do here is that we have discussed about AI application to DevOps and quality engineering is the need of the hour. We definitely need to do that because the IT landscape is becoming complex. Our traditional techniques of standard testing, standard automation, standard development, standard code reviews might not be enough for us to to be able to deal with the complexities of different techniques, multi-speed IT, different complex hybrid environments, cloud and on-prem, and then all that aspects. So we definitely need to utilize data analytics, machine learning, and AI. Then we spoke about that what is DevOps, what is data analytics, machine learning, and AI, and how before starting to talk about I need to implement something on predictive analytics, something on machine learning in my DevOps pipeline, in my testing pipeline. Before that, we have to step back and we have to look at where the data is coming from, what is the quality of data, how am I gathering that data, how am I structuring that data, where that data is going, before we start applying any of this. Because the problem is, many a times, in fact, we have been situations with some of our customers where there is a real urgency in terms of doing a pilot or a POC on utilizing predictive analytics for risk-based testing or for coverage analysis. And after so much of effort of actually building algorithms, building some sort of, we realize that the quality of underlying data is so bad, and it is so what you say, non-standardized. Team A is using and storing requirements in some particular fashion and test cases in some particular fashion. Defects are not being traced properly back to the requirement. So the quality of underlying data is so poor that all the effort that we try to do to kind of make some sense out of that data is just waste. So after we have kind of stepped back and thought about how we will get the data, it is also important to see what are the use cases, what am I trying to achieve, or what all we can do actually with utilization of the data analytics, machine learning, and artificial intelligence. What do I want to achieve, or what are those use cases or objectives that I'm trying to implement? There are certain aspects which are I would say process related. There are use cases which are very hardcore tool implementation related, and then there are use cases which are kind of a mix of process and tools and technology aspect of implementing or utilizing or leveraging AI for DevOps and quality engineering. So streamlining requirements management, this is one of the use case that in fact we are right now working with one of the very large healthcare customer. They are actually looking at utilizing some sort of uh, pattern analysis to identify, like there is a huge amount of requirements, unstructured requirements data, which is in a very unstructured format. So utilizing aspects of NLP, trying to utilize certain keywords to identify patterns from that requirements document, and then pick those requirements, sort them, structure them in a separate folder and things like that. So that there is in fact a very serious, significant effort that has been going in that space. I'm sure a lot of you are aware of, there are some traditional requirements management tools like which used to support a lot of unstructured like not fully structured requirement documents like doors and some of the other tools. looking at requirements, specifically healthcare organizations are struggling now with managing those type of requirements in when there is whole this DevOps transformation, agile and things like those happening. Having your legacy system requirements in a completely unstructured format is not helpful. So looking at AI and machine learning in that area, how can that use case be tackled, can be one aspect. I won't go in each and every use case because otherwise it will take a lot of time. Quality engineering, there are multiple use cases, starting from hyper automation, utilizing techniques like visual AI testing or smart coverage analysis to see that what is the actual code coverage versus what you're probably, many a times you have unit testing reports that tell you 95% coverage, but the real coverage is maybe 40% or 50%. So smart coverage analysis, utilizing trend analysis, past coverage data to uncover the coverage related issues, that definitely is a use case. Industry has already started using RBT, risk based testing and test optimization, seeing what requirements change eventually trigger defects in which areas, thus giving me a prediction of where, if I change something, what are the areas that I should definitely focus on testing. That use case again is pretty mature. A lot of organizations have started using that. Again, you need very solid traceability from your production defects or production incidents back to the actual requirements that eventually triggered that production incident to be able to do that kind of prediction. But once that data is there, that algorithm or that use case is pretty, I would say, straightforward to implement, again, with the caveat that eventually it depends on your traceability from incident back to the requirement change. So there are a lot of use cases in that space. Then coming to, if you look at the whole operations aspect, definitely the whole smart collaboration, there is that terminology that is being used in the DevOps industry, that how do I make my dev and ops collaboration really smart by analyzing the past performance data of how, what changes in development triggered to what reliability issues, what operations issues, what maintainability issues, and those type of aspects to improve the future collaboration of the dev and operation team. So that use case again, pretty, I would say, looking at the definition of the use case, very simple. Look at the past trend data, what development changes or what code or what requirement changes triggered what kind of RAMs, which is reliability, availability, maintainability, and security issues, and how can we prevent them in future. It looks very simple. Eventually it depends on the data. So if I have to implement this use case, we have to go back, step back, and see from the entire pipeline what are the data elements that will be key in building this kind of use case. And then there are security related use cases, threat monitoring. We all know that security is at the forefront of entire, for every CIO's like priority list. It is probably the topmost, specifically with all the remote working and all that getting heavily opened up during the pandemic. There is, security is at the forefront. And with the whole complex infrastructure, microservices, the number of alerts many a times that security teams are getting, or the threat that indications or alerts, unless there is a utilization of some kind of data analytics or machine learning algorithm, it is humanly impossible for any security analyst to sit and track all the alerts. So definitely that is a use case. Many organizations have started already implementing techniques around that. So there are multiple use cases on the development, operations, quality engineering side, where data analytics, machine learning, and AI can definitely help in transforming the quality engineering and DevOps space. The whole, I would say, from the summary or the conclusion standpoint, it is important. Data is the king. How we collect data, what are the various stages in the DevOps pipeline that can give me meaningful data? How do I trace that each stage of data for me to give us a specific trend analysis or a specific prediction or a auto healing capability, taking it to the next level of like cognitive type of environment where system can recover from a past configuration issue or a past, there was a production failure which was led or which is due to a specific configuration all the time that fails, and the system learns from it and auto recovers by making that configuration change every time that production issue happens, and recovers from it on its own. All those things are possible. Bottom line is, collect the right data, identify the use cases. For each use case, identify what data is needed, process that data, create a model. Obviously there is a model training aspect, the model quality engineering, the whole aspect, and that's where we start touching upon testing for the AI systems, and I don't want to get there right now in this conversation. But yeah, with that I would think that even my time is kind of over, and Pradeep, I'm a minute over my time, so I'll just pause there. In fact, this was my last slide,
Okay.
and I'm yeah. So
No, that's really lovely. I would have not wanted to stop you because I was certainly starting to feel like a dinosaur, when I was hearing all the developments that were happening there. And it's really nice to hear. That's the best part of being in a conference, right? Like you get to see the futuristic and the proactive work that organizations do. And I'm really happy to note, especially the takeaway for me has been the cognitive DevOps. And I think that's where the future is headed to. And I think organizations are going closer to adopt cognitive DevOps in a very serious way. And I think it'll not be any more DevOps. I think it'll probably be DevSecOps, as you rightly said, because security is a critical issue in the current new normal that we are all going to live by, where everything is going to be online for a large amount of time. And the only good thing I felt was like, that if it was a real event, we would have missed this particular talk. So thanks to the pandemic, we could have you online and we could have your word reach out to everyone in India. Really appreciate you taking time late in the night, Anjali, and really appreciate it. We will continue our conversations with questions from the audience as well. So we will send you those questions. We'll send you those feedbacks. We certainly would like your support in, giving some perspectives when you hear from them.
Thank you so much, Pradeep. It was a great opportunity. I enjoyed, and I hope I was helpful. Some of
No, certainly.
something I learned something from Mahesh. So that's the purpose of the whole conference. Thank you so much for the
Absolutely.
opportunity. It's definitely lovely. Thanks.
Pleasure, ma'am. That's great. And for the audience, we will have a small break for 15 minutes, but you could use that time, to go through the various expo area. The next section of the conference will focus on the seminar hall. That's where you'll see different tracks where each of the presenters would be presenting on different tracks as per the agenda. So you can look at the agenda, go into the relevant track, listen to the best practices that we have shortlisted from the conference submissions this year. These are all individuals competing, for the best of the best awards, which we will announce tomorrow. As always, this year also we have jury members in the audience, who are also attending these sessions and who will also be reviewing some of these best practices. So a quick suggestion to all the speakers in the relevant tracks: when you go in, please introduce yourself, just tell your name and the company, need not explain your bio, and then straight away get into explaining the problem that you've identified and how you solved it. So far, I hope it has been very enlightening. We've seen how, as of now, we have seen how AI is going to play a critical role in the future of quality engineering. And we've also seen some perspectives from Anjali on how AI can be leveraged, to improve our quality engineering and transformation aspects. We will meet again in 15 minutes, from now onwards. pick up a cup of coffee, feel fresh, get warmed up, and please do post your questions, as well. We have a mechanism to see these questions and track them and speak with the speakers on these questions as well. We'll see you in the individual tracks. Thank you.